Welcome to this presentation. This recording is a new recording. I gave this presentation recently to a large UK-based compost producer, and I wanted to record it separately for the benefit of those who weren't able to see this presentation in person. So the cheeky title, "Can compost value increase tenfold?" will be explained in a minute. What I'd like to present here is the idea of creating a supply chain for agriculture that is based around biology rather than chemistry, and I will explain how that biology can replace the chemistry and how compost plays a key role in creating that biological based agricultural supply chain. So let's begin. The fertilizer and crop protection markets combined in the UK are worth more than £1 billion per year, whilst the compost sales are between 100 to 200 million. And this is where that cheeky title comes from. If I was, or if somebody was to create a product or create a system which would replace the job of chemicals in agriculture, which are worth more than £1 billion per year, then that thing, in essence, would be worth that kind of money. And so if that was the case with compost, then the perceived value of compost would be that of the combined fertilizer and crop protection products. So this is how I look at it. And so the connection that I'm looking for is how that compost can do that job. And so to start understanding how this can achieve it, is we have to look at what kind of biology we can get from compost, because it is the biology that has historically provided the nutrient and protection to plants, and we through agriculture have come to a point where that biology is not present anymore. And so the biology in aerobic compost is composed of four main groups of organisms. It's the bacteria, the fungi, protozoa, and nematodes. And bacteria and the fungi are the little fertilizer factory. So they go out and they mine the rocks of the soil, the sands, the silts, and clays, and they take those minerals, they put it into their bodies. There are nitrogen fixing bacteria which will take atmospheric nitrogen and again store it in their bodies. And then there's the micrograzers or the predators which eat the bacteria and the fungi, which are the protozoa and the nematodes. Farmers have battled nematodes for decades, but they have battled the root-feeding nematodes. So there are detrimental nematodes in the soil, but there are also beneficial nematodes in the soil, and those beneficial ones are the ones that we'll be making through aerobic compost. Just for the sake of interest, the not so beneficial nematodes actually can form in anaerobic composting. So moving on, the jobs that microbes can perform. Plants, basically the terrestrial plants, they just put down the roots into this microbial soup. Microbes had been around on Earth as long as Earth was cool enough for life to form. So microbes have been there first, and then when terrestrial plants started evolving, they simply plug it into a system which already existed. And the system is as I mentioned, microbes will mine the soil for nutrients and they will capture water. Plants require soluble forms of micronutrients, and micronutrients are not only in soluble form in the soil, They're also in exchangeable forms. They stuck onto the surface of the particles, of physical particles of the soil, and they're also locked in the minerals themselves, which we call the total pool. And also microbes, they produce glues to stick together. You know, bacteria don't have hands, so they have to hold on, otherwise rain comes and they just get washed away. So they produce glues and they stick to each other, and they stick to these soil particles that they want to extract minerals from. And so they form these micro aggregates. They stick together, they form these micro aggregates. They pull together and they separate, they pull apart and they separate into these little micro aggregates. And then fungi comes along, and the fungi basically grow these hyphae, and these hyphae will group some of these micro aggregates into macro aggregates, so you can actually see these macro aggregates. And when you have these macro aggregates, then you have pores in the soil. And when the soil is porous, then water can actually infiltrate. Whilst water is infiltrating, it pulls oxygen down into deeper layers of the soil. So everything is aerobic, everything is breathing like we are breathing. So if you have now a structure in the soil that holds water and allows oxygen to get through to deeper layers, then if we look at what kind of composition of that soil food web, as we call it, is, that actually determines, it's a predictor for us of what kind of plants, what groups of plants will grow best. And we look at the fungal to bacterial ratio of biomass. And if we have just bacteria, if the soil is just forming, then the happiest are weeds, because they'll pick up any soluble nutrients in any water that's available. They'll grow very quickly. They'll put all that energy into seeds. They'll disperse the seeds and they die. That's it. That's what they do. The detritus from these plants now lay on the soil and they add to the organic matter, so that's a good thing. But that's basically a happy land for weeds. Then if we look at sort of productive pastures and our arable crops, then the ratio of fungi to bacteria in that soil usually is about 1:1 for healthy soils. So then what does it actually mean? I mean, what does it mean to the plant? It means to the plant that, for instance, nitrogen in a bacterial soil is mostly in nitrate form, whilst in a fungal soil is mostly in ammonia form. So if you have an equal amount of fungi to bacteria, then you've got a balance of ammonia and nitrate provided to the plant. And some plants require only nitrates and some plants require only ammonia. If you were to put nitrates into a forest, it will kill your trees because it's actually toxic to these plants. Trees only take up ammonia; they don't really take up a lot of nitrates. So then our pastures and our arable crops, they take a balance. They can work with either. And so if we are to provide the conditions, we need to provide certain balances of these microbes. And just for interest's sake, if you were to have a productive orchard of any kind of soft fruit, you want to have 5:10:1 fungal to bacterial ratio. So then if you have all of these microbes, I mean, where do they hang out? Obviously they're in the soil, but then if the plant is putting down roots, the plant is actually taking a lot of the energy from the sun that it's put into this chemical energy. So it's producing all these sugars and protein, and it pumps a lot of that into the soil, and it pumps that in essence to get a response back. So when it does that, it provides the carbon fuel for that microbial biomass. And so these microbes, they hang around the roots because that's where the food is. It goes out the root, it gets immediately taken up by these microbes. So now you've got this this layer of of microbiology that is completely covering the roots. And if you have, obviously, if you have mycorrhizal fungi, then that extends even further. But in essence, all of the roots in a healthy soil are covered, completely covered by beneficial bacteria. And so if that's covered by beneficial bacteria and all of that is aerobic, all of that is oxygen rich and the water is free flowing, then no disease really is forming. And if any disease is forming, they don't really have a chance to compete with the beneficial bacteria because they just don't have the conditions to grow. And so the plants are basically protected against disease in that regard. And then when it comes to pests, they usually the subterranean pests like the root-feeding nematodes, they don't have eyes. So the only way for them to see the plant is to smell it. And so if you have a plant that's completely covered by biology, any kind of chemical substances that come out from that plant get captured by that biology. And also, if that plant is well fed, it's healthy, it doesn't produce chemicals that signal to the pest that the plant is unhealthy. Because in natural systems, how it works is that a plant that is stressed, that is unhealthy, it produces these signals, and these signals basically say to these pests, oh, okay, it's time to take that plant to the dumpster. So they basically collect that that matter. This is now something that needs to get taken away. This is obviously your old survival of the fittest. So here you've got a plant that is unhealthy, it needs to be taken away. So then if you have a healthy plant, it's completely covered with these microbes, no chemical signals come to the pests, there's very little pest pressure. And there's also another factor. When you have root feeding nematodes are a huge issue, but if you have a healthy soil food web in the presence of the roots, then one of the elements in that soil food web could be predatory nematodes. And these predatory nematodes, they're 3 times the size of your root feeding nematodes. They have a big tooth in their mouth, and what they do is they hunt the root feeding nematodes. And so they feed on them and they get rid of them. They're like missiles. They just hone on to the, again, chemical signals. They don't have eyes either. They just hone in the chemical signals released or left behind by the root feeding nematodes. So the idea is that if we have that kind of biology in the soil, then the chemicals are not necessary anymore because the plant is fed. We don't need fertilizers, and the plant basically is in control of what it needs and when. We just apply fertilizer once a year or twice a year, and the plants will take some of that up, and 80% of it leach into the soil and then into waterways. So that's a big issue. So the idea is if there was a supply chain that people can simply plug into, where the farmer can simply plug into, then it will be just a matter of I'm not going to go to the agronomist today, I'm just going to go to the people who have this biological system. So the new supply chain would be composed of a mixture of, or a combination of biology-based products, and these are derived from compost. Without that, you can't have the rest. Without the biology-based product, you can't have the rest. And compost, properly made, aerobic compost, is the key, is the center of that new supply chain. So that's why it's such an opportunity for the large-scale compost producers. They can be in the center of something that is about to explode. It's a market that's just forming. So then you've got these biology-based products, and then you've got some way to apply these products onto the farms, and there will be people who will produce machinery, and it's just not just machinery to produce compost, to apply the compost but then there's application of extracts, there's producing compost tea, there's applying compost tea, And there's also no-till equipment because it is best actually not to disturb the soil. So that exists already as well. Agronomists will be retrained, or a new breed of specialists will be formed, like myself, the soil food web specialists. And so this whole supply chain can be formed. Everything is in place apart from that biology. Wherever you go across the UK, there's a handful of people who make it in very small batches, but there is no one in the compost producing industry, in large volume producing industry, that has taken it on as a key development. So that isn't available yet, and so that is a huge opportunity there. So why is it relevant to look at this biological supply chain? Why now? And I see that there are certain risks in agriculture. These are clearly visible in the news even. The first risk I put in is the risk of losing a license on glyphosate. So what is glyphosate? A lot of people have heard of the chemical Roundup, which is a popular store-bought weed killer. And that's in Roundup, glyphosate is the main ingredient. In agriculture, glyphosate is used on its own. And the issue with glyphosate is that recently it's been marked as a known carcinogen. That's one. The other issue is based on that. There has just recently been a landmark case where a person who was a groundskeeper in the States, he contracted or developed terminal cancer. So this person will die, unfortunately. We're talking October 2018. And he sued Monsanto, the producer of glyphosate, and won. And this is now causing an issue for the legislators and for the farmers, because it's the most popular weed killer. So people have been using this product for many years now, and you know, after its approval, it's been the mainstay of the weed killer industry. So there's another issue with glyphosate. It's actually stopping to work because certain weeds have become resistant. They've become Roundup ready, as the industry calls it. And one of them, the ironic development is that one of the plants that is now touted as superweed is amaranth. And amaranth is the first domesticated grain. So Mother Nature basically said to us 10,000 years ago, here's a grain for you to use. We've used that, and now it's saying, do you know what, guys, you could use amaranth again. And amaranth has been sold to people in the health industry as a superfood as well. And so if we don't solve this issue, then we can just all switch to eating amaranth again. We might not have a full wheat bread, but you know, at least we can eat amaranth. So that's one issue. So the weed killers are not working, and the main weed killer is about to be withdrawn. So then there's soil erosion. We lose uncovered topsoil to wind and rain. Rain is the most eroding factor, and we lose about 2 tons per acre per year of topsoil, and that carries off organic matter. Organic matter is necessary to bind soluble nutrients. So soluble nutrients are, again, the only form that plants can take up. And then the question, how old are your children, is tied to the levels of phosphate that are predicted, that are available across the planet. The way phosphate is one of the 3 main nutrients that are provided to plants through artificial fertilizers. So you've got nitrogen, phosphate, and potassium. Nitrogen, phosphorus, and potassium. So so phosphate is at the moment mined, and it's depending on who you read. They give us 50 to 100 years worth of crops, 40 to 60 years worth of crops, and there's also a more recent study that suggests that we're left with 30 years of mineable phosphate. So if that's 30 years, my daughter is 8. So by the time that she's got children, the age of 8 to 16, say, does that mean that she's going to run out of food? So that's an issue. That's a huge risk to agriculture. Then there's the cost. The cost of these products is tied to the cost of oil. Cost of oil is a very volatile commodity in terms of its cost. Just a 2% change in production just sends it on a huge swing up or down. And then there's the case of peak oil. We don't know when we're going to run out. So the cost will keep going up. The other issue is climate change. We're being told that droughts and flooding are on the rise. Well, not just being told, because this year we saw a huge drought across Europe, and there have been a lot of farmers affected in the UK. And then there's flooding, and just a few years ago, it was in 2014, we saw flooding in the UK that covered quite a lot of land, and that has to do with water just falling onto slopes and not being captured by the soil. So it just sheaths off. So it just goes off and doesn't stay in the soil. And that is an issue that could be resolved by biology, and we can get to that. I'd like to mention the work of the Environmental Agency in this particular field, because that's how it's all tied together. So you as a compost producer, you have to abide, you have to get a license, and that's done to prevent pollution with nutrients. So pollution with nitrates, pollution with phosphates. All of these things, they produce algal blooms in the waters. Because if you have a high concentration of these nutrients in water, a little bit of the sun, and all of that surface of water is being covered with very, very actively multiplying algae. And this algae then, it just keeps on multiplying, taking up all these nutrients, just like we talk about the microbiology that's around the root. It just picks up all of everything that's available. It gets sucked up. So the algae keeps on growing on this freely available nutrient. And first of all, let's talk about like where this nutrient comes from. But because obviously you don't produce all of that nutrient because you had to, build that slab of concrete, and you had to, do all these other things to prevent that runoff. But in agriculture, if a farmer spreads fertilizer onto their crop, the plants only take up between 15 and 20%. Actually, it's between 10 and 15% of that nutrient, and the rest goes off with the rain. And so, up to 85-90% of what is actually put onto the fields ends up in water. So that's why we have these riparian areas beside the rivers with a lot of trees and shrubs to pick up some of that nutrient, that freely soluble, water soluble, plant available nutrient. But when it does end up in the rivers, it creates these algal blooms, and these algae just keep multiplying, and then there's this huge mass of algae, and then the lower layers, they start dying off. And when they die off, there's other microbes that consume that dead matter. And so when they consume that dead matter, they consume oxygen. And so that happens very quickly. And so, oxygen doesn't penetrate water very well. And so that oxygen gets used very quickly, meaning that now the microbes that would live in oxygen-rich environment, they die off. And microbes that live in a anaerobic environment, oxygen poor environment, they start flourishing. And you end up with an anaerobic digester in your river. And we all know in the industry what an anaerobic digester does. It just kills off everything, and it just rips it apart basically into simple molecules. And so we've got stinky rivers, you've got dead zones just outside the river mouths in the sea. And so the environmental agency wants to prevent that. And so this is key for them, key work for them. They obviously have to make water pure enough to make it drinkable for humans, and they want to prevent floods. And we'll see how it all ties together in a minute. One more thing is that consumers actually want organic food. In the UK, the last 6 years saw an increase of 6% per year of demand of organic produce. And before that, there was a dip. Just after 2008, when the recession hit, everybody said, oh, organic is expensive, let's go back to eating normal food. And that's where the dip happened. Before that dip, there was a high, which basically the trend before that lasted for 20 years. So people have been buying organic food more and more year on year until 2008. And then there was a dip. And now we're going again 6% per year increase in demand. And now it's higher than it was in 2008. So it's going to continue. We're looking to continue that trend at the moment. The problem is that the supply doesn't match. And here's the thing. Farmers also want organic, and they want organic for various reasons. And these reasons could be the increased margins, so purely economical, and also they care for their soils. They really do. I mean, these people grow up, with this whole environment, and they love this place, and they just want it to flourish. They want it to be healthy. Soil really is like another animal on the farm. It's like a stomach when it's healthy, and when it doesn't have the proper biology, it's an unhealthy stomach, and it just it can start smelling. So they want organic, and how do we know that they want organic? There are two conferences. There are main farmer conferences in the UK. One is the incumbent Oxford Farming Conference, and it's been around since 1932. And this conference is basically sponsored by the likes of Monsanto, Bayer, McDonald's. There's people in suits who come and talk to the government. They come up with ways to ensure that their interests are being represented well. And then there's the Oxford Real Farming Conference, which was formed about 9-10 years ago as an alternative to the Oxford Farming Conference. And it's on the exactly same days in January, and what happened is that in 2018, what they noticed was that the attendance of the Oxford Real Farming Conference was twice of that of the Oxford Farming Conference. And the other thing they noticed is that 83% of the attendees were farmers. I mean, when I was there, you could see people in wellies. So these people are on the ground, farmers who are looking for solutions to move away from chemicals and exchange ideas and just come up with new ways and learn from each other and learn from experts that are appearing in the field. So they want that. And there's a lot of early adopters, there's a lot of pioneers. So we've had the pioneers, there's now a lot of early adopters that are learning from the pioneers. But to reach the majority, I mean, the majority, is just stumbling against this wall, or just hitting this wall, because there's a risk. To be certified organic, it takes 3 years. And in those 3 years, you have to stop using the chemicals that you've been using for decades, the chemicals that have provided for your business and the business provided for your family. Suddenly, you have to stop using them. And what do you use instead? And it's a costly process. There is a person who comes to your farm, and you have to pay for all the tests and all that sort of stuff. And in the meantime, you could lose your crop. That is a huge risk to them. And so, yes, they go out. Yes, they get educated. Yes, there are certain places where you can get advice. But there isn't one turnkey solution. This is that supply chain that I mentioned earlier, that opportunity just doesn't exist yet. So How can you help? When the farmer starts applying the biology which is produced from your compost, they stop using those fertilizers. The plant gets their nutrient, as we mentioned before, from the interaction of the microbes every second of every day, whenever it needs it, on call. And so there isn't a huge runoff of organic nutrients. So the environmental agency sees you now as the ally in protecting waterways, because now the composting industry is in the center of this solution. And so yes, you will need to get a license so you don't create this problem, but you are now the solution. So you would be seen as the ally to that part of the agency's work. The farmer saves money on chemicals. Remember, the market for the fertilizer and crop protection is more than £1 billion. And if the compost, the whole new system, is seen by them as worth that £1 billion per year, but you come to them and you double the price of the compost that you're selling now, that's going to be a big deal for them. That's still going to be a good deal for them. They're still going to save money. And moreover, we know that you are in a situation where you take green waste from the councils and you have to get rid of the product because you just got paid by the councils, and some farmers are smart enough to know that you have a problem getting rid of it because you produce so much. But if the case was that you had gold instead of just putrefied organic matter, then basically that wouldn't be a case of them saying, yeah, drop off the material here. It would be a case of, this is a valuable product now. We're going to be selling it for that amount, and people will be lining up to pick it up. So because they're still going to be saving the money, and they will be getting all the benefits of the biology that's in that compost. So then legislators and the farming industry, won't have a problem when glyphosate license goes away, because the soil will be ready for it. Nobody's going to have a problem because, when the glyphosate license goes away and somebody says, oh my God, I didn't prepare a solution for that, I wasn't ready, they can simply come to the soil food web expert or the retrained agronomist and say, help me, and they say, yeah, sure. There's the compost producer over there. There's the extract making service there. There's this, that, and the other. Here's the test we're going to run on your farm. Everything's going to be done. So they just need that turnkey solution. Councils, obviously, they're, as much as we might not like it, they're political places, and they like to see themselves as part of the solution to the problems that face society. And so they can put it on their books. Look, we provide all this waste, and that waste is being turned into organic produce in your store. So it's a closed loop system, and we talk more and more about closed loop systems. And that leads us to the public. The public can purchase more organic produce, and that's going to be cheaper. The more people produce organic produce, the cheaper their inputs, the better price the organic produce will be, and it's going to be better value as well. Because if the plant is healthy, if that microbiology is present, then the plant has got the full spectrum of minerals and vitamins in it that it should. It puts down its roots deeper, it takes more. So it's just better for us as humans. So our children will grow healthier, will be calmer in school, and we're just going to benefit all around. So to be able to take the next steps, basically, the farming community has seen the pioneers. People who have looked at this under the microscope have been there. A lot of work has been done. We've got enough knowledge to start. There's still a lot of work to be done. We still know less than 1% about the soil, seriously. But in terms of the farming application, what we know is that we need to provide a diversity into the soil. So the pioneers have done that work. the early adopters are now taking that and applying that into their fields, and they're seeing the benefits. So the thing is that momentum is growing. We just need to go to that early majority phase, and this is how you help, basically. This is when you control your processes to the point where the end product contains that biology and you do it at scale. This is where we can reach the early majority, because now the product is just available across the country. Now the product is available in any quantity that is required. So if you look at the Oxford Rural Farming Conference again, the classes on soil health are just full. I saw, I went to one class and it was just packed so tightly that people were being chased away because of fire regulations, fire hazard regulations. And so I saw a person put his ear to the glass in the door, and I just stood up, walked out, and let him take my place, because he needs to learn this this methodology, whilst I already know it, so it would be just a waste for the farmer. So at the moment, again, we're just coming to that issue that they have to do it themselves. And if we create that new supply chain, and that supply chain really is ready, everything is in place, it's just that product, that base of biology that's required. That is the leap forward. We're just going to have a step change, not a small progress. We're going to have a step change from this early adopters to this mass market. And you can be, as a compost producer, you can be at the center of that new supply chain. And that is the great opportunity. If we're looking at 100 to 200 million pounds composting market, we're now looking at a 200 to 400 million pound composting market. I mean, doubling the market value, just the value. I mean, I'm literally talking about increasing the price double, at least. Because even now you can buy a worm compost which will be 80p a liter. And that worm compost not necessarily will be full of the soil food web that I described. It might actually have different ratios. Something that would benefit brassicas but wouldn't benefit your potatoes. So yeah, so there's still an opportunity to get a lot of value from the same material that you're producing now. And you can't just switch. You've got a lot of things to resolve to be able to participate, and that is quite understandable. There's the cost of machines. There's differences in the type of material that you get throughout the year. Some material would be more nitrogen rich, which would benefit more bacteria. Some material would be more carbon rich, and logistically, these things matter. You've got space, you've got the cost of the space, you've got the limitations imposed by the environmental agency as to how much compost can be put onto the fields. And again, if you have good quality compost, that will not matter. So so you have all these barriers, but this is all workable. This can be actually overcome. This will require a project, and some people who maybe are on a smaller scale might do it quicker because they're more nimble. Some larger companies have got a much greater opportunity, but they'll have a longer project because of the machine that they have in place right now. But I think for the large scale producers, that's a much bigger opportunity even. And if the medium scale producers picks it up, they could grow as a market leader very quickly. So what if you don't pick this opportunity up? Now, I've put this here. It will sound cheeky. I do risk being a salesman by putting this thing in, but I think it's worth thinking of, just like you build any business case, is toward thinking of what is the cost of status quo. What could happen if we don't take that opportunity, if we just continue working as we work now. And so I look at everything. I look not just the composting industry, but the farming sector. And so obviously the councils are being squeezed for money, and some of the things that they want to save on is gate fees. And if they have an opportunity, some councils have now introduced to their residents the opportunity to have their garden waste picked up, but at a cost. So they have to pay an extra 20-25 pounds per year to get their brown bin picked up. And what we see is that a lot of residents don't do it. They don't even want to spend the extra 20-25 pounds, and some of them just burn it in the garden, some of them just put it in the corner of the garden and just let nature deal with it. And so now the volumes of the materials might start coming down. With the volume of the materials start coming down, the councils are looking at reducing the gate fees, and now we're looking at gate fees between 20 and 50 pounds a ton. And for some producers, it's hard to get above 20 pounds a ton. So if in the past it was easier to run the business just on gate fees, now it's more challenging. So what will happen to composting sites if that goes away? So then I mentioned, it might be easier for small to medium size entrants to start making this proper biology, because there's less amount of people and they just can act quicker, but they have less resources. So again, large companies can actually utilize their resources to leverage it and do it properly. But the small entrants can do it quicker, and they might, on that basis, when they show results, they might just be quicker than yourself. So somebody will take that opportunity up. Phosphate, we talked about that. Will we run out of it if we have the biology we want? But if we don't have the biology, we will. That's it. It's, whether it's 30 years or 100 years, we'll just run out of it. It's just like with oil. Will the farms be overtaken with weeds and we'll be just eating amaranth? Who knows? And then there's a question about toxins in our food. Glyphosate, that very popular weed killer, is also used as a defoliant, meaning that the farmers have been sold on the idea that to prepare for harvest of wheat, they basically, a week or a day before the harvest, they go out into the field and they spray a large amount of glyphosate, larger than actually used on weeds, to kill the crop. And that basically is like a means of chemical drying of it, you might say. It's not chemical drying, but it kills the plant. The plant dries out quickly, and then it's ready to harvest all in one go. So people have been sold on this idea, and now if you and I go to a lab and we put a sample of urine through the lab, we will show glyphosate in the urine. And when people switch to organic, in 2 weeks' time, that's gone. So at the moment, there's a big experiment run on the entire society. Like, what's going to happen if you continue putting glyphosate in our food? So, it sounds like a conspiracy theory. It's not. It's been demonstrated by science. So the solution to flooding and drought: microbes build structures in the soil. So if we have poor soils without structure, we will continue to see flooding and drought. That's it. We will continue seeing, and there's another thing. Soils capture carbon. I mean, microbes are made out of carbon just like we are. And so if a fungi grows its hyphae, the hyphae actually is mostly just a carbon tube. And in a forest soil, in a healthy old growth forest soil, 85% of the weight of the soil is fungi. It's not even the sand, silt, and clay. It's actual organism. So we'll need to come up with other solutions if we don't create this biological supply chain for agriculture, which creates the opportunity to, which creates the opportunity to resolve that. Going back to increasing the value tenfold, where do you start? We start with checking your compost. You've made your compost, you've got this pile of, this large brown pile of sifted compost that you sell to the nurseries or sell in, put it in bags. Send a sample to me. We check under the microscope what is the composition of the soil food web. And if you already have that biology, then we can go through the process of how to market it, how it is supposed to be labeled, how is it supposed to be sold. If not, then there's other steps. First of all, we need to decide, you need to decide if entering this market first is of interest. And if it is, then let's talk about what steps can be taken to get from now to having that amazing product and having it in the hands of your clients. So your clients will need to be involved in that process, and all the other steps in the middle before we profit. So here's my details. You can reach me under the phone number present and also the email ti.soilecologylab@gmail.com. My name is Daniel Tilkiel, and I invite you to have a chat, invite you to have me come to your site and see what is your reality, what are your constraints. Let's talk about your constraints, but let's talk about the opportunity, and let's talk about the first steps. And when we go through the first steps, we might talk about what is the value of making that shift, and we can look together at the costings and gather the information necessary. So I invite you to contact me, and I will be posting some other information in due course, so that I can provide you with some more information to make a decision. So thank you very much for taking the time. It's been almost 50 minutes of me talking, so thank you for taking that time, and hope to hear from you soon. Bye bye.